Multivariable calculus is the extension of calculus in one variable to calculus in more than one variable. The differentiation and integration of functions involving multiple variables, rather than just one. Typical operations. Limits and continuity. A study of limits and continuity in multivariable calculus yields many counterintuitive results not demonstrated by single variable functions. For example, there are scalar functions of two variables with points in the domain which give a particular limit when approached along any arbitrary line, yet give a different limit when approached along a parabola. For example, the function approaches 0 along any line through the origin. However, when the origin is approached along a parabola, it has a limit of 0.5. Since taking different paths toward the same point yields different values for the limit does not exist. Continuity in each argument is not sufficient for multivariate continuity. For instance, in the case of a real-valued function with two real-valued parameters, continuity of infafixed and continuity of infafixed does not imply continuity of. As an example, consider it is easy to verify that all real-valued functions that are given by a continuous in. Similarly, all a continuous as is symmetric with regards to in. However, itself is not continuous, as can be seen by considering the sequence which should converge to if was continuous. However, thus, the limit does not exist. Partial differentiation. The partial derivative generalizes the notion of the derivative to higher dimensions. A partial derivative of a multivariable function is a derivative with respect to one variable with all other variables held constant. Partial derivatives may be combined in interesting ways to create more complicated expressions of the derivative. In vector calculus, the del operator. Introduction to Calculus and Analysis Volume 2. Springer Science and Business Media. ISBN 9783540-66570-0.